do this over 2 sessions. The first session is going to be on all the skills people need for the trilogy course, the combined award course. The triple course, I've got some more skills, but I'll do those next week for you, okay? So I'll go through those next week, do the same sort of thing. And the skills, each of them individually, are pretty straightforward. The challenge is knowing when you see them in an exam paper. And so I've got you today a whole bunch of questions that come from exam paper to give you a flavour of what they're like, okay? So the very first skill I want to spend time on, this is really easy, but I guarantee it will be a mark on your paper. That's calculating the formula mass of a compound from its chemical formula, okay? Sometimes that's given the symbol M with a subscript R, and that is, by the way, the mass in grams of 1 mole. And we'll talk a bit about moles in a bit. And so the kind of thing you'd have to do is maybe add together and work out the formula mass of magnesium chloride, or do another one, calcium nitrate. And for that, all you've got to do is to add together the atomic masses of all of the substances, all the elements in the compound. So for magnesium is 24, and there are 2 chlorides, so 35.5 and 35.5, which is the atomic mass you find on the periodic table. So 71, add 24, comes to 95. Okay, so that's how you do that. We'll practice this in an exam question in a bit. Where it gets a little bit harder is where you've got substances with brackets, and this is where sometimes people lose really easy marks because they're not really sure what the brackets mean. What the brackets mean is that the substance or the elements within the bracket are all, in this case, times by 2 because you've got a 2 on the outside there. Okay, so there's 1 calcium because that's not within the brackets, but the nitrate is twice, so nitrate is 1 nitrogen, so in total there's 2 nitrogens, so 2 lots of 14, because each nitrogen is 14, and there are 2 lots of 3, so 6 lots, and oxygen's got a mass of 16, 6 lots of 16, and if you add those lot together, I've done it quickly, but if I've done it right, you get 164, okay? So that skill comes up quite a lot, and it's surprisingly often that people sort of slip up on that. Or people don't realise how easily you can get marks from it. The second skill, and I will come back to the first one, it will come up in questions that we're going to do, is to do relative atomic mass calculations. And these are the numbers that you get on the periodic table. So the numbers often with decimals associated with them. And I'm not going to define isotopes with you right now, but you might remember that, well, I won't go over it in detail, but you might remember that isotopes are, oh, by the way, I just found an example of a question here. 2 marks look for working out the relative formula mass of sulfuric acid. So 2 lots of hydrogen plus 1 lot of sulfur, the numbers are given to you even, plus 4 lots of oxygen, 4 lots of 16. I'm pretty sure that comes to, I'm just going to check it. $98, yeah, that's right. So 98. So that's all you've got to do for that. It's really straightforward, but it comes up to 2 easy marks on your paper. The calculation of relative atomic mass, you might remember that isotopes are 2 versions, or if you like, 2 versions of an element with different numbers of neutrons but the same number of protons, and so they will have different mass numbers. So in the question we're about to do, it's talking about chlorine 35 and chlorine 37. They've both got 17 protons, but this one on the left has got 18 neutrons and this one on the right's got 20 neutrons, which is the difference between 35 and 17, or 35 or 37 and 17. And what you would get, it's usually set out exactly like this, is a table like this. And this is, again, a really straightforward question that people can pick up easy marks. And in the mock, we had a question like this that people slipped up on. So you've got to multiply the mass of an isotope by its abundance, by how much of the sample contains, or how much of the sample is isotope chlorine 35. So multiply these two numbers together. So it's 35 times 75.77. And you add that to 37 times the other number. And this is exactly the same skill as you do in maths. I think you do weighted averages in maths. It's exactly the same skill, really, just a chemistry version of it. And I'm a bit silly because I haven't got the mark scheme here, so I have to just tap that into my calculator. But if anyone beats me to it, I'll take your answer. And the answer is always going to be in between these two numbers. So if you've got a number that isn't in between 35 and 37, you know you've gone wrong. This one's telling us that the question tells you to give the answer to 2 decimal places. So in the calculator, you've got a much longer number, but you only write it to 2 decimal places. And often with those, you have to do some rounding, not in this particular place, but it's 35.48. Okay, so that's all you've got to do there. So it's a pretty straightforward skill, but make sure it's on one of your flashcards when you're practicing and so on. Okay. The next question we're going to do, which is one that you don't often spend much time teaching because there's only so much you can do with it. It doesn't take very long to cover, but it's often therefore something that is quite easy to slip past. So the third skill we're going to spend time on today is something called percentage by mass. I'll do a couple of examples. Hello, it's all right. Just to let you know, I'm videoing, so if you want a question, stick your hand up, I'll pause and go from there. All right. So percentage by mass is a really straightforward skill, but we don't practice it that much in class possibly. So if you're asked to work out the percentage by mass of, say, let's go back to a substance we were using before, magnesium chloride, it's not, or some of the mass is due to magnesium and some of the mass is due to chlorine or chloride ions. And you can work that out by doing a simple percentage calculation. Let's say I'm asked to work out the percentage by mass of chloride in magnesium chloride. Well, we know the total formula mass is 95. We worked that out. So it's just a percentage calculation. Each chlorine is 35.5, and there are 2 of them. So 71 as a percentage of 95, you know how to do percentage calculations. It's just that. So 71 divided by 95 times 100, and that comes to 74.7%. A really straightforward skill, but it's surprising how often people can't do it. I'll do another example which I know people often get wrong. A kind of funky compound called ammonium nitrate. And the first thing to do is to work out the formula mass. So we add together 14 for the nitrogen, 4 for the 4 hydrogens, another 14 for the other nitrogen, and 3 lots of 16 for the 3 oxygens, which is 48. You top those up, and you end up with 80 as the formula mass. So it's a percentage of nitrogen that's making up that 80. And there are 2 nitrogens. Each nitrogen has a mass of 14, so it's 28 divided by 80 times 100. Right? Really easy skill. A couple of dead simple marks that people often miss out on, 35%. And that came up in 2023. And it was 4 marks, believe it or not. 4 marks for this skill. It's such an easy skill. Okay, so what you have to do, what I'm going to do actually is pause it and get you to do this one to make you work a little bit. Can you try and get those 4 marks? Let's go. There are 4 lots of 16, which is 64, divided by 110, times by 100, which you're telling me is 58. And you're right, you have to give the answer to 2 sig figs. So 1 mark would be simply for writing it to 2 sig figs. 1 mark for working out that and stick it in the equation. 1 mark for doing the sum right. It's really, I mean, that's 4 easy marks, right? It couldn't be easier. And it comes up every couple of years. Right? Dead simple. That's another skill then. That's 3 skills ticked off. Should we keep going? You happy with that? Sure? 4. I haven't got many questions on this. It sort of comes up in one question that I found. There's very few questions on this. But this is a question, this next skill, so conservation of mass. Is the simple idea that whatever the mass of the reactants are, so let's say A and B, that will equal the mass of the products, right? So I've deliberately picked non-named compounds here. Let's say that was 10 grams. This was 15 grams, and this was 5 grams. We can work out what the mass of B must have been, or the mass of B that reacted must have been, because whatever they add up to must equal those, because you can't create or lose atoms. Right? So it must be, this adds up to 20, so this must be 10, right? It's simply that. That's all you've got to do. And it's really surprising how often when that question appears, people don't get it because they don't realise what it's asking. But just watch out for the conservation of mass. The only times that happens, the only time it happens that you lose or gain mass, sometimes you lose mass in a reaction if one of the products is a gas. So let's say D was a gas, that would disappear off into the atmosphere, leaving the product C being only 15 grams, but that's it. So the best example of that I can come up with is a question that I've got here, which I'll come back to in a minute, if that's all right. I'll teach you something else because there's a second skill as part of it to make that question. Okay, so we'll do that after we've done skill 5, which is calculation of number of moles. And everybody needs to know this calculation. This will 100% come up in your exam. Most students in the school are doing triple award, and you need to be able to work out moles from volume of gas, from volume and concentration of a solution, and from mass. But for trilogy, you only have to work out moles from mass, and that's what we're going to do. The skill for the triple that people struggle with is working out moles, and they're not given mass, yet they use the wrong equation. So to work out moles from mass, you have to do the mass, and you have to have it in grams, and then you have to divide by the formula mass, which is what we worked out at the start. And that's the answer. That's all you've got to do. All a mole is, little reminder, is it's an amount of something. And so 1 mole, we learn, is Avogadro's number of something. You don't need to know the word Avogadro's number, but it's that enormous number, 6.02 times 10 to the 23. Right? So if you've got 1 mole of something, you've actually got 6 with 23 noughts after it of that thing, right? So that's what we mean by 1 mole. You can work out the number of moles by taking the mass of a substance and dividing it by the formula mass that we worked out in skill 1 a minute ago. Let's show you an example of how that might be tested in an exam, perhaps using the exam question that uses also conservation of mass. So in this reaction, you're told you've got magnesium reacting in a crucible, and it's reacting with oxygen in the air. And you heat it up, give it a blast. You measure the mass before and afterwards, and you're told that magnesium reacts to give magnesium oxides. So this is not a balanced equation, so I'm just going to use the words to make it really nice and vague. And it's reacting with oxygen to give. Hello, miss. Well, in this question here, you've got magnesium and oxygen reacting together to give magnesium oxide. And you're told you've got 0.12 grams of magnesium. You're told you've got 0.2 grams of magnesium oxide. If you set it out like this, it's so easy to see how many grams of oxygen there that were used up, right? Which is 0.98, yeah. So the mass of oxygen used is 0.2 0.08 grams, and you get a mark for that. And then you have to work out the number of moles of oxygen there were using the mass over MR thing. So this, you can see why it's worth 3 marks, because you've got to work out the formula mass of the oxygen, which is 16 add 16 equals 32. And then you do the equation. I haven't set this out very neatly, but the moles is equal to the mass in grams divided by the formula mass. So it's 0.08 divided by 32. Did anyone actually work that out already? The moles is 0.0025. Yeah, that's all you got to do. So it's applying these basic skills, 3 different skills in one really simple calculation, is where frankly people get thrown off, and it's understandable why that might be. Sometimes, though, just going to add a little extra detail to moles calculations. It's really important you understand that the calculation is moles equal to mass in grams divided by the formula mass, because the formula mass is the number of grams per mole. And often, in fact, nearly every case in the GCSE in the last few years is given the mass not in grams, but in kilograms or milligrams. And I've seen a lot of very, very good students, top students, giving the moles, but out by a factor of 1,000 because they haven't converted to grams first. So if you're going to I'll do 2 pretend examples with you. Let's say you've been told you've got 72 milligrams of, I don't know, magnesium oxide we'll use as an example. You have to work out the number of moles. The moles is equal to that in grams, which is 72 divided by 1,000, which is 0.0072. Have I got that right? I think I've got that wrong, haven't I? I'm up it. It's 0.072, surely. Just going to check it, make sure. 0.072 divided by the formula mass of magnesium oxide, which is 40, and then you get the moles by doing that. So you must convert to grams first. Very often, though, it might be in kilograms. So it might be that you're told you've got, I don't know, 1,020 kilograms of aluminium oxide. And so if you're working out the number of moles of aluminium oxide, you've got to do moles is equal to the mass in kilograms, turn that to grams, so 102,000 divided by the formula mass, which is 102 for aluminium oxide. Okay, so all I'm doing is converting to grams first, because 1 kilogram is 1,000 grams. Are we happy with that as an idea? Yeah, really, really common, so make sure that's on your flashcards. Remember to convert to grams first, right? Where it gets a bit tougher is where we're going next, though. So this is the big one then. So this is where we're going to spend a chunk of time. I've got a couple of examples, and hopefully you can work through at least one entirely by yourselves. So this is what we call reacting mass calculations. And it's extremely likely that you'll get this in your paper 1 somewhere. Often worth like 4 or 5 marks, right? A heap of marks, and you can do this. They will often give the question, should I just do one from 2020? Should I just do a question? Just do it straight away. So you've seen this before. But the idea is that you're given a balanced equation, and you're told some information about that balanced equation. You're told, for example, as you are in this case, that you've got a certain mass of gold, and we can't do anything with mass apart from work out the number of moles. And with my classes, as some of you know, if you're not sure what to do with these calculations, first thing to do is always work out the number of moles. We can do that very quickly. We'll do that together in a particular way in a moment. But if you look at the equation for a second, it's important we understand that the molar ratios here are the crucial thing, right? So however many moles of gold that you've got, gold is AU, there are 1.5 times as many moles of chlorine, and it will produce 2 moles of gold chloride, right? We've been asked to work out the mass of chlorine, so that's really important we work out the mass of chlorine. So I quite often in my when my lessons are from an exam paper, I'll highlight really clearly what I'm trying to work out, because some people here work out the mass of gold chloride with this question, and it really clearly says give your answers in milligrams, so we've got to times by 1,000 at the end to turn it into milligrams, and again that's often forgotten. So the way that I would teach this and encourage you to do it is to set out the equation again so we don't make any slips. And I'd write down underneath the things that we know. So we show the examiner we know that the molar ratio is the same as in the question, the numbers, the coefficients in front of the symbols in the balanced equation. We're told the mass in grams of gold, so let's put that underneath the gold. We show the examiner we know we've got 0.175 grams of gold. And we know that we can work out the number of moles of gold using the skill that I just practiced with you, right? You can work out moles by doing mass divided by MR. So we'll write down the MR. Now, when you're using the MR, again, a little tip for you, and again, people got this wrong in the mock exams, even though we've been through this plenty of times in class, is that when working out the MR, it's the MR of the thing in the red box. You don't need to multiply by, in fact you mustn't multiply by the number, the coefficient there. So the formula mass of gold is simply whatever it says for gold on the periodic table, which I can't see, but it's 197. So the formula mass of gold, 197. So we can work out the number of moles, which sometimes give the symbol N, by doing the mass over the MR, which is 0.175 divided by 197. And then I'd encourage you there to write this out with plenty of sig figs. You can do the rounding later on. You could write this in standard form if you prefer. I probably would personally, but I don't want to add confusion where it's not necessary. So that's the number of moles of gold, and you've picked up at least a mark, possibly 2 marks at this point. Can't remember the mark scheme. But you're asked to work out the mass of chlorine, which you can't do until you know the number of moles of chlorine. And you can work out the moles of chlorine by, and you should show this in the exam paper, that you're timesing by 1.5. Thumbs up if you're clear why you multiply by 1.5. Do you know why you're timesing by 1.5? Yes or no? Yeah, so it's simply because to get from 2 to 3, you've got to times by 1.5. So you times that value in the calculator. Notice I'm leaving, can you see that? Not really, but the big long number in the calculator, yeah, times that by 1.5. Don't round it for the calculator, round it onto the paper, and that comes to 0.00133. So that's the number of moles of chlorine, and the formula mass of chlorine is whatever's in that red box, which is 35.5 and 35.5, 71. So these questions tie together all the skills we've been working on so far, right? And then you might have to rearrange that equation. So number of moles is equal to mass over MR. And you should be very comfortable with flipping that around. Mass is equal to Mr. Moles. And some people prefer to learn it like this as well. But you imagine a little character called Mr. Mole. Right, so mass is equal to Mr. Mole, as long as it's in grams. So we take the mass and times it by the MR, the formula mass. So that number there, 0.00133, times by 71, you can show they're timesing together by doing that, is equal to, and you might want to write it down here to be really clear to the examiner what you're doing. And that comes to 0.0946. It's appropriate to give it to 3 significant figures because all the questions in 3 significant figures. But that's in grams. What have we got to do to turn it into milligrams? Yeah, times by 1,000. Yeah. So take that number there, times it by 1,000, and you get, don't want to make a mistake on this, so it's 94.6 milligrams. So that's, I mean, to me, that's more or less 3 marks. Easy peasy marks. I've got another one of those somewhere that I'm going to give you to do I'll pause the video and you can have a little think about it if I can find it. Might be in here. Okay, so have a go at this one now. Did you get time to write all that previous one down? A bit to, I'll leave that up so you can see it, but you're going to have a go at this question now. I'll pause the video. Yeah. So, as before, write out the equation again. I think it's good practice to do that. This is the Haber process, and so this is actually an equilibrium reaction, which you'll do, spend the session on another time. You've been told you need to make 25 grams of ammonia. So start off just by before by writing the ratios, the molar ratio, which is 1 to 3 to 2, and the mass in grams that you've been told in the question is 25 there. You write down the MR for each of the substances. You don't really need the nitrogen, but I'm going to write it down anyway. Remember, it's only what's in the box there, which is 2, and ammonia is 17. So you work out the number of moles of ammonia, just N in moles, by doing the mass. It's probably good practice in an exam to show you the equation you've actually used. For 25, we'll do it like that. So 25 divided by 17, which was what, please? 1.476. And then from that we can work out, can't we, the moles of hydrogen. This time it's a 2 to 3 ratio. So you can either times by 1.5, or if you prefer, divide by 2 times by 3. I like times it by 1.5, so we'll do it that way. Times that by 1.5 and you get what? And I like that you've used lots of sig figs there, and we can round at the end. That's the right way to do it. And then to work out the mass is equal to the moles times the formula mass. So it's that number times 2. So it's 4.412, right? Yeah. 4.412, or just in fact when we round it to 2 sig figs is 4.4. So I made a little mistake in there. 4.41. Wow. 4.412 grams, and we're asked to do it in grams this time, so it's just 4.4 there. So what you got? You got the same thing? Yeah, well done. Good. Happy days. Right, so frankly, they're all the skills bar one that you have to do for trilogy. There's quite a few more for triple, which we'll do next time. But there's one more skill I want to spend a bit of time on, and that is when you have to work out the limiting reactant. Okay. So sometimes in the papers they say it tells you which one's the limiting reactant, and that tells you then. Actually, there is another skill beyond that. It's concentration calculations. I'll do that as well. The concentration calculations. This is the next skill. So let's write this one down. I forgot one of the skills. So question 7. So skill 7 is concentration calculations. And for trilogy, it's just in grams per decimeter cubed. You don't have to know about moles per decimeter cubed, but for triple you do. And the equation is concentration is equal to the mass divided by the volume. And the units are grams divided by the volume, grams per decimeter cubed. Per just means divided by, right? So concentration in grams per decimeter cubed, our mass in grams divided by volume in decimeter cubed. Dead simple. And so if you get a question like this one here, you're told you've got some lithium sulfate, and it's in 25 centimeters cubed. The challenge possibly for many people here is to spot and know what to do when they see that the information given in the question is in 25 centimeters cubed, but we've got to convert it to decimeters cubed. So that's the first thing I would do. So 25 centimeters cubed is equal to 25 divided by 1,000 decimeters cubed, which is 0.025. Okay, so that's going to get you a mark to start with. So simple. Just check the units match up. Are we happy with that? I promise you'll get asked to do at least one of these in the exam where you have to convert from either grams to milligrams, centimetres cubed to decimeters cubed, is 100% guaranteed. The concentration is the mass, as we just said, divided by the volume. Plug the numbers in, job done. 0.30 divided by 0.025. I reckon that comes to 220, but I'm doing that in my head, so I'm not sure. What is it? Has anyone done it? Right, I'll do it then. So 30, 1200. 12. All right, I'm just doing it in my head, so I'll just check it. 1200. If you do 0.30 divided by 0.025, it's the same as timesing by 4. Same as that. It's 1200. Oh, I can't type. It's 12. You're right. Well done. Always good when it's me that's made a fool of. There's plenty of opportunities for that. So I hope you enjoyed that. Good, lovely. Right. So that's concentration calculations. Again, 3 really simple marks. Even though you drop one now and again, like I just did. Let's now look at the last skill we're going to do today, which is limiting reactants. I spent a fair old chunk of today going through past papers to see how many trilogy papers have got limiting reactant comments in them. Almost none. There's hardly any. So this is not a big concern of mine, and it's only ever worth a mark or 2. But sometimes they will say, well, this one is the limiting reactant, or this one is in excess. And so you just concentrate on the one that is the limiting reactant. The limiting reactant is the one where if you had, let's say, 100 pens and only 50 lids, the limiting reactant is the one which determines how many pens with lids you can have. The limiting reactant is 50 there, so you can only have 50 pens with lids, right? If it was a person with shoes, you had 50 shoes and 50 people, the limiting reactant is actually the shoes again, because you need 2 shoes per person in most cases. So the limiting reactant is 50 shoes there. Because you can only get actually 25. You can only 25 people can wear the shoes, if you see what I mean. Does that make sense? That was a funky example I used there, but never mind. Very occasionally, I've seen questions where you've had to work out what the limiting reactant is, and I've got a few of these on this worksheet. But these give us an opportunity to practice all the other skills we've been doing as well. So it's quite nice little questions here. So you've been asked to work out the mass of sodium fluoride formed when you've got 2.3 grams of sodium and 2.8 grams of fluorine. There's a special way of doing this that I'm not a fan of, but the exam board asks, so I'm going to do it the way that they want you to do it. Okay, so please do it this way. So again, set out the molar ratio. Just to show the exam board we know what we're doing. It's 2 to 1 to 2, and then fill in what you know, which is the mass in grams of the sodium, which is 2.3, and fluorine, which is 2.85. We don't know which one of those that we're going to use to work out the amount of sodium fluoride produced yet. There's a little way to do that. Nevertheless, we can pick up some easy marks. So even if we can't work out the limiting reactant, we can work out the number of moles of both of those by doing the mass divided by the formula mass in each case. So the number of moles is 2.3 divided by 23, which is 0.1. And we can do 2.85 divided by 38, which is the formula mass of fluorine, and that comes to 0.075. So we're picking up marks for working out the MR, we're picking up marks for working out the moles, and then we get a mark for working out which one is the limiting reactant. So if this is hard, don't sweat it, right? It's not the biggest thing in the world. The way they want you really to do that is to work out how many moles you would get from each of those possible scenarios. If that was the limiting reactant, how many moles of sodium fluoride would you get? Well, the answer is it's a 1-to-1 ratio. So you get 0.1 moles if that was the limiting reactant. Fluorine has got a 1-to-2 ratio relationship with the sodium fluoride. So you times that by 2, it's equal to 0.15. Right? So whichever of these is the smallest number, that's the one that's the limiting reactant. It's telling you here that's the sodium. So it's whichever one produces the smallest amount of sodium fluoride is the limiting reactant. Okay? So the limiting one is sodium, and we use that number there to work out the number of moles of sodium fluoride that's produced, which is 0.1. Multiply that by the formula mass, which is 23 and 19, 42, and so the answer is 4.2 grams. Okay? So I'm going to pause the video at that point and give you a different question to try along those lines, because it's still practicing a whole bunch of other skills. Okay? So I'd like you to try this question here. All right, so exactly the same as before. You write down the masses of the substances, divide them by the MRs, and you get those moles of iron oxide and aluminium. Work out how much iron they would produce if they were the limiting numbers. The smallest number is 0.08. You use that then to work out the number of moles of iron. Times it by the formula mass of iron, which is 56, gives you 4.48 grams. And it might be in a real exam you have to convert that to milligrams or kilograms or whatever. Yeah, really good. I hope that was useful, but well done. You did really well.